Hey everyone, welcome to this month's Serverless London Meetup. Today we've got two great talks, one by John Fancey talking about Azure Logic Apps, and then Jan will be talking later about AppSync. Before we get started, I just want to thank Theodo and Senzo for sponsoring the event. And just to remind everyone, if you've got any questions, put them in the live chat as we go. There's just a small delay, so we don't want to miss them during the Q&A. Anyway, John, would you like to get started?
Yeah, thank you. Hey, everybody. Let me just get my slides up and I'll tell you who I am. Okay, hopefully everyone can see my screen. I'm John. I work for Microsoft. What do I do there? I'm a product manager on a product called Logic Apps, which I will get into momentarily. Yeah, as you can see, I'm kind of usually based in the office kind of behind us, but like everybody else, I'm at home right now, which is great for this sort of thing, because I'm actually able to kind of join you guys and do this. So without further ado, let's get into this. So what I want to kind of cover here is, I'm not going to assume you know what Logic Apps is, but I'm going to assume you know what things like workflow engines are, and really that's what the heart of Logic Apps is. And obviously, you know, because we all love serverless, I kind of explain kind of how Logic Apps is serverless and kind of what that means for us on the team, and directionally kind of, you know, what that kind of means, I think, honestly, for the cloud as a whole. I want to show you what Logic Apps is because it's very visual. So obviously that's always the best way to see things anyway, right? By kind of doing some demos. And I'm probably going to focus on kind of what's new as well, because Logic Apps has undergone some pretty significant changes in the last few months. So if you are aware of Logic Apps and you kind of know what it is, then treat that as a kind of a refresher in terms of what's the sort of latest and greatest with Logic Apps, because some of the changes are pretty significant and pretty interesting. So and obviously then, you know, if you're interested in learning more, then I got a few pointers there for you as well. So, you know, what is Logic Apps? Well, in 60 seconds, basically, it's a serverless, codeless workflow engine. So that means, you know, it's event-driven, it's on demand. It works by being able to connect up events with actions. And that's done through having a rich library of connectors that are built in. So a connector could be anything from an HTTP trigger, which, you know, everybody kind of provides support for, but it could equally be something from a SaaS application like OneDrive or Slack or something like Salesforce.com or anything else. Anything else can basically provide data and kind of cause something to happen and drive an event, essentially invoke a workflow instance in our engine. And because it's serverless, it's consumption-based billing, so you pay for what you need and only when you need it. But it's also low code, and this is kind of interesting simply because, you know, there's a big industry shift going on right now, and it's not about kind of developers kind of not wanting to write code. It's about getting more productive, right? Being able to do kind of more with less time as the tools get more and more sophisticated, simplifying some of the toil, some of the stuff that kind of isn't much fun anyway, and actually abstracting that away and kind of focusing on the problem you're trying to solve. So what do you kind of use this thing for, right? It's kind of typically falls into the kind of so-called integration space. So as part of what we call an integration platform as a service, which is essentially a serverless integration platform, because it has all these connectors, which is what you kind of see in the background here, you know, a whole bunch of icons. There's you know, about 400 or so connectors that we have right now, and you can even build your own. So it's a great way of being able to connect things together visually. But as well as that, you can do things like automation. So what's the difference? You know, integration is often about just connecting systems together and kind of in a fully kind of connected and integrated way. So you connect your trading partners to your you know, line of business systems. You can then connect the line of business systems to your accounting systems, so that, you know, maybe you have an e-commerce website, and this can act as the back end of that. And actually have, you know, workflow orchestrating all the different pieces of your application on the back end, accessing databases, accessing systems of record and other things, to be able to quickly and easily kind of build out what are essentially business processes using workflow and the workflow paradigm to be able to do that. So there's really three kind of key concepts here. I've mentioned one already, which is connectors, and you create connections to connectors. But the other one is triggers, which is the way the event-driven model works. You start off with a trigger, and that's where you specify where the stimulus is coming from. Which system, which SaaS application, which APIs, which protocol you're going to use to invoke that workflow, and just kind of hook it up. And then you use things called actions, which is basically the intent. This is kind of what I want to do. And this is everything from data manipulation of being able to kind of shred arrays, kind of pull elements out, generate kind of messages or data that then gets pushed to downstream systems, kind of mapping between different applications because the protocols and formats are different, and implementing the business logic. So graphically being able to represent things like if else's and do untils and for loops and switch cases and other things are all kind of represented in the language behind Logic Apps. Because although it's low code in its paradigm, there is a JSON representation behind that, which is sometimes easier to manipulate, particularly in code, because we kind of have full APIs and command line interfaces for this, so you can programmatically create a Logic app. And you can sort of build it up step by step to define what it's going to do, and that's all kind of represented in JSON with a published schema that we provide, which I'll provide a link to later, so that you can kind of understand it. It's not just about the kind of graphical designer. There are other ways of kind of authoring Logic Apps as well. Right, so kind of just like know the space, right? It's like where does Logic Apps kind of stack up against other things you may have heard of if you're not familiar with Logic Apps. And this is a very kind of loose mapping, if you like, because actually all three clouds offer something different, but of course there's overlap. Everybody has workflow engines. In fact, when you look at this, we've all got at least two, basically. So AWS has step functions, which is a way of kind of typically orchestrating Lambdas. It also has the simple workflow service as a more kind of first class workflow engine, but step functions is kind of a state machine based workflow engine as well. Google Cloud has cloud workflows and also something called Cloud Composer. Now, Cloud Composer and workflows together is very similar to what Logic Apps provides, because it gives you the workflow capabilities and it gives you the kind of connectors and connectivity that Logic Apps provides as well. And then on our side of things in Azure, we have Logic Apps, of course, but we also have something called durable functions, which is a code full workflow engine experience. So it's sort of more analogous to something like step functions, where I can write code against our kind of workflow framework SDK or APIs, which allows you to then implement the business logic and the intent of the workflow, and of course use Azure Functions to do that. Okay, so why serverless? Well, I think it's pretty interesting because as I said, workflows are used to implement processes, and because processes are often unpredictable, you often don't know when the load is coming and how much load to expect. So it works great for processes which have an unpredictability aspect to them, and even when we look at kind of usage data all up. Most usages you'd expect is driven by businesses, and those are driven by kind of the Monday to Friday effect. So even in like the worst case, if you like, you typically save money on the weekends when things are quieter, depending on the workloads and what you're doing, because you're not paying for compute all the time. I mean, sure, everybody here, like us, you think serverless is honestly the future of the cloud because of this, because you're really only paying for what you need and when you need it, and exactly the kind of right amount of it. So it has this kind of infinite scale feeling, right, where you don't have to deal with that stuff, and that works great for events where things like Black Friday and other things where you're just anticipating a much higher spike in load. And that gives you the ability to just save money, pay for what you need, but also I'll kind of optimize around the kind of back end kind of operations of this as well, because you're not having to manage a whole bunch of stuff in aggregate all the time when you only need it for some of the time. The other aspect of this is, a lot of processes are often mission critical, right? They're business critical as well. So, there could be financial or reputational loss as a consequence of, your e-commerce site not being available or some other aspect of your business being down. So again, by taking the effort away from having to manage the business processes and the the traditional way was going to use process management software, business process management software, BPMS, is often expensive. Combining these things together gives you a lot of reliability and predictability around the things that you're implementing, so that you can kind of, again, focus on the problems that you're trying to solve, the applications you want to build, and not have to worry about timer jobs and other things all kind of firing at the right times and having to kind of keep an eye on all of that stuff. All that back-end infrastructure is all taken care of for you. So by kind of up-leveling to focusing on the problem and focusing on the processes you're implementing and using a serverless workflow engine to do that, is actually a very kind of powerful construct. Okay, so why low code? Well, it's kind of similar that having the ability to define more visually what's going on can make it easier to model complexity. Because it's certainly true that if you look to the equivalent in code for very complex workflows or set of workflows, you may be able to understand it because you authored it, but when somebody else comes along and takes a look at it, it takes time to be able to read through all the code and understand what it does. When you can see essentially a picture of it, you can see the flow kind of laid out in front of you, and the steps and the things that are being connected to and everything else. It can be easier to grok. It can be quicker to understand, and therefore safer to kind of maintain that and make changes to that, so that you kind of don't break things, and you can extend with ease and with low risk. Obviously, the thing I think most people focus on with workflow engines and the fact they always, typically almost always have a graphical component to them, is productivity. But I think there's more to it than that. There's an opportunity here that Logic Apps embraced of how to take hard computer science problems and simplify them. So what do I mean by that? Well, it's things like, just a few examples here. Things like if I'm doing message-based processing, where I'm kind of pulling messages off a queue, and I want to be able to process them in order, or I want to be able to process each one of them exactly once. So I kind of want these transactional semantics, which are very hard and often not optimal to implement for the cloud. And maybe I want to do that at a very high scale, so I have lots of instances pulling pulling or polling data from queues simultaneously. So I kind of have this competing consumer pattern going on as well. How do I ensure that I get exactly one's delivery there? And a workflow engine like Logic Apps can make that very, very easy to be able to do, because it kind of deals with the coordination that has to happen on the back end of that, the locking of the messages and the putting them back and the rollbacks and everything that occur if there's a failure in that workflow, so that another instance can pick it up and process it, all kind of seamlessly happening. And kind of related to that are things like, the massive parallelization problem that you get when you look at cloud architectures, and very distributed ones at that. How do I, and workflow engines are very good at this, how do I parallelize problems and kind of do these fork and join scatter gather patterns, are very amenable to workflow engines themselves, and being able to depict that in a designer and in a graphical way as well. Then there's other things like kind of being able to reliably schedule things. You may want to schedule jobs that run 6 months or even a year in advance, right? And then maybe just run on an annualized basis. And that's stuff that, unless you are keeping an eye on it, you may discover it's not going to work when it doesn't work, right? You set up something now to run in a year's time, and it's like, and forget about it. And you find out in a year's time that something went wrong, the servers that it was running on, or some other infrastructure changed, and it fails, right? It doesn't run at all. So a lot of that stuff gets abstracted away as well. And there's a few other kind of interesting patterns which Logic Apps enables as well. Things like batching and depatching. Yet another interesting kind of computer science kind of pattern or problem, where, well, how do I have the ability to be able to group things together and then process them as a set? So maybe you want to group all the orders together and process them, on an hourly basis. So orders kind of come in and you kind of batch them up, and then you just release that batch and let that go based on some criteria that you set. like like every hour or every 1,000 orders or something else. And that allows you to do things like load leveling, protecting backend systems, but also being able to sort of schedule things to happen at the times you want them to happen. So you kind of have a disconnect, deliberate decoupling between the data generation on the one side and batching that up, and then the release and processing of the downstream of that data at a schedule or different time period that you define. So there's some kind of interesting things that happen in there. There's also something in Logic Apps called a split-on pattern, which says, well, if you start with an array that as the input to that workflow, then it will automatically shred that array into the individual elements and kick off a workflow instance per element. So imagine you were kind of, and this works great for connectors that again kind of pull data in chunks. So imagine you're pulling data from something like Twitter, and you kind of pull it every hour, and you have like 1,000 tweets in an array as the input. So going back to kind of this event-driven model, it then will shred that into 1,000 elements and actually kick off 1,000 workflow instances simultaneously, because there's no relationship between any individual elements in those arrays. So it's an instantly parallelizable problem, and you get much higher throughput when you kind of implement patterns like that. Another one is kind of accuracy. You can focus on the what, not the how, basically. Again, they sort of working at a different level of abstraction. And what I mean by accuracy is that when you look at the kind of workflow definition, we can ensure its correctness. When you write code, you kind of find out through compilation and through deployment and testing whether there's any errors in the code that you've written. But when you express it graphically, there's a whole bunch of checks that can take place to ensure that the workflow definition is valid, i.e. it will run successfully, and that reduces the testing effort to determine that it is doing what you expected it to do, right? But I would say, don't panic. It's like you can still write code in Logic Apps. It has integration with Azure Functions. It has something called inline code, where you can actually just write code right there in the designer, which is great when you just want to just write a few lines of code to do something that is actually easier to write in code than express graphically by drawing boxes and kind of connecting them together. Very useful for simple mathematical functions and other kind of functions where you just want to perform some operations on a set. Can be easier just to write a couple of lines of JavaScript to be able to do that. And of course, there are other things that kind of spring to mind when you sort of start panicking about, well, it's not a developer tool. Like, how do I do things like deployments, DevOps, CI/CD, and other things? All of those things have been taken care of as well by being able to kind of plug into the sort of developer tool chain, so that you do get the kind of management and deployment and everything else that you would expect to be able to kind of use this stuff at scale. Otherwise, it kind of falls apart, right? You just end up with too much stuff. And as you become a victim of your success, when it kind of collapses underneath you, because you just kind of keep track of everything that's going on and all the different artifacts that you need to put together to deploy this thing as a unit of functionality. And then there's also true with making sure that you have great debugging and testing, so you still get the in or out of loop experiences and things like VS Code, IDE support. So you can create Logic Apps in a variety of ways. As I mentioned, you can do it through a command line interface or through a set of APIs, which actually are what power the VS Code integration. You also go to the Azure portal and kind of create it and just create a workflow right there, in your favorite web browser as well. But as I mentioned earlier, the easiest way to kind of understand what it is and what it does is to look at it. So with that, I will just quickly pop across to Visual Studio Code. Now, this is a new extension that we published only about 6 weeks ago. So what I'm going to do here is I'm going to create a new workflow, new Logic app, and it asks me a question. It said, do you want to create a stateful workflow or stateless? Now, stateful workflows is what we've had in Logic apps since the beginning, the last few years. Basically means that that reliability I talked about is enabled by persisting the state to storage between every action. So if an action fails, you can kind of restart, or we can restart on your behalf, and we can set retry rules, and you can try 3 times and then give up and kind of wait a certain period of time between retries and all of those kind of great things. But there's a performance penalty with that because of all that storage persistence. So stateless workflows is new and gives you the ability to get much faster execution of workflows, which can be one of the problems with workflow engines all up. It's like, they're great, but the performance doesn't match what you would get if you just wrote the code to do it yourself, right? So stateless workflows are designed to overcome that, remove all that storage persistence. Obviously, then you kind of introduce the problem of that reliability. So it works great for things like HTTP, where the caller is aware of the failure because they'll get an HTTP error back again, right? So for these single shot kind of request response type patterns where you're using workflow to go to a backend service, using one of the connectors to go and grab data, maybe aggregate it with 2 or 3 other things, return the result back in a few hundred milliseconds, it works great for those kind of scenarios, because if you can design it to be idempotent, then if the caller receives an error, they can try again and no side effects. But for this, I'm just going to create a stateful workflow. I'm going to helpfully call it stateful 2. And you see right here, this is a logic app, right? There's this kind of not very interesting, but you see it's got a definition, and this is the JSON template I was talking about. So I can kind of go over here and I can actually open this and see the magic of the designer. It's going to take a few seconds to spin up. And here it is. So I kind of see these kind of two panels here. I see it asking me, what's the trigger, right? So how am I going to start this thing? And then I have this kind of configuration panel, which allows me to sort of configure each one of these steps. So I can just pick requests, and I'll get into some of the options in a minute. And it basically, like, when an HTTP request is received, create an instance of this logic app and give it control. And I create another step, and I can pick request again and actually set a response. And I could just do a simple echo and just set the body of the response to the body of the request. You can see that, when an HTTP request is received, I can grab the body, so you can kind of see how I build these things up. And I could save that and just run it. But of course, there are other things I can do. You see I have these things called built-in actions and also Azure-based actions. So built-in actions are things like the logic and control that I have. So I can have conditions. So this is analogous to an if-else. I can sort of pick the true branch, and then maybe I want a for each. And I can set the parameter of the for each. I don't have any arrays. If I set the JSON schema on the initial request, you can see I can provide a schema for the input data. And if that specifies an array, then what will show up here on this for each is the ability to then pick that input data as an array. But to my point about having correctness and accuracy of the definition, Logic Apps is smart enough to know how to wire up types together so that you don't kind of have incompatibilities with what you're trying to do with the data. If I don't have an array, then passing an array in is going to cause it to not work properly. But if I know what I'm doing, and maybe it's a string that I'm going to turn into an array that I'm receiving, I can do a CMOR. I can still pick the body, right? And I can then, I'm in control. I know what I'm doing, and I can decide to kind of do some additional processing on that. Because there's plenty of other things I can do here with things like data operations that say, I can compose, I can take an input and create an output from it. We've had things called expressions, which allows me to sort of use mathematical functions, string functions, date time functions, and other things. So I've got lots of ways of generating and working with data, including these actions like being able to create a CSV table, HTML tables, filtering arrays, pulling elements out of an array, merging arrays, even parsing JSON to be able to kind of manipulate the data in there and selecting the data out of it. So lots of different things I can do. But honestly, for this, I'm literally just going to try to get the Zoom window out of the way. I'm literally just going to delete all this stuff. Oops. And I'm going to delete that. I'm just going to save this as I said. Now I'm just going to run it. So it's just start debugging on this thing. It's going to, right, yes, I knew it was going to do that. So one issue on my machine, which I will address right now, is that it actually uses Azure storage, as I mentioned. So I am running this on a Mac, and we don't have support for our storage emulator on a Mac right now. That's something we are working on. So, and it's actually set in 2 places here. So I just need to find the workflow runtime. And there's another setting, local settings, because it clears this one out. So let me just fix that. I will go back to my workflow. Oops. And let's try that again, start debugging. Hopefully it doesn't give me an error this time. It's going to spew some output in the window. Basically what it's doing here is kind of wiring everything up. It's taking that logic app definition. So this is new. I'll talk about this in a second, but this is actually deploying it to run on top of the Azure Functions runtime. So what you're seeing here is a generation of the wiring up of the Logic App workflow instance, which is JSON based, and creating the trigger in an Azure function to be able to dispatch work to the Logic App when requests come in. So what you kind of see in the output window here is that it has my new stateful2 workflow. You see I have another couple in this project already, but it provides and generates, because it's going to receive an HTTP request, it generates an endpoint for that. So I can grab that endpoint and I will just pop over to Postman. And actually, yes, sorry. What I need to do here is grab the full endpoint because it has a full URL on it. So if I just pop up and have a look at the overview, it should generate the full endpoint for me here, like the callback URL. And I can just paste that in Postman. I set a post verb on it. That's actually the default. Like we support all of them. And then I can just say, set the body, just say hello. Oops, type, and then send that in. And it's going to run that Logic App and send a response back. First time, as I said, it kind of hooks things up, so it's a little slow. It gets quicker once it's warmed up. But you see it's just echoing the response back to the window there. And if I kind of come back here and I'll just refresh this and have a look at the workflow again, looking at the overview, I can then see the run history for this. So this Zoom window is in my way. You probably can't see it, but I can. So this is actually the run that I just did. I just called it, invoked it, created an instance, ran it, sent the results back, and I can actually look at that run. And this is really what the whole sort of storage persistence powers as well, and actually see that, you know, an HTTP request was received. It had a body of hello, and it sent a response back. Yeah, it allows me, you know, a simple ability to kind of debug retrospectively, right? So if I had an error, imagine I had thousands of these things being invoked, then I could look back at one of the instances that failed and even filter by the failed ones and fix them. And maybe even do a resubmission of the Logic App if it was a transient failure. Maybe I'm calling it back in a system that was down or wasn't available. So I can just resubmit those Logic App instances with the original trigger data without having to go back to the system that kind of called me, you know, maybe that application front end. I don't need to go back again. So again, in that e-commerce kind of website example, I don't need the customer to kind of redo their order through the web front end. I can just resubmit it on the back end because we have all of that state. And can then, once we've figured out what the failure was, resubmit in bulk and ensure they all run to completion successfully. Okay, so let's go back to the designer. So let's have a quick look at a couple of other things. So you see we have a number of built-in things besides logics. So we also have things like event hubs built in. So the reason we did that, actually having some of this connectivity built into the engine, is for performance and very high throughput. Event hubs is a great example of that, of being able to process, you know, very high volumes of events. We're looking at kind of doing more of that based on kind of the characteristics of some of the services we see people wanting to wire up together with workflow and with Logic Apps. Because we have a huge number of connectors, as I mentioned, nearly 400 now, which is what you see here. So if I kind of stroll down this list, you can see, you know, it kind of goes on and on and on, and you can kind of filter the list and search for the ones you're looking for. Obviously, you know, you see all the Microsoft Azure services, but you also will see services from Google. You'll see services from AWS in there as well, things like you know, SQS and other things, so that you really can start to join clouds together with this this capability, with this service, of being able to pull data from one cloud, process it, and then push it to another one. Okay, kind of looking at time now. Right. So a couple of other things I just wanted to cover quickly. Logic Apps kind of fits into this thing called an iPaaS, this integration platform as a service. And this is really about, like, how do I build applications? How do I implement these critical business processes? I need more than just workflow, right? So we connected to things like Event Grid, which provides our event substrate for being able to publish and subscribe to events, again, from any cloud, because we support CNCF cloud events. So you could emit and publish events from GCP and consume them in a Logic app over in Azure, right? You may want to use full messaging. So this is where Service Bus comes in. If you're familiar with things like RabbitMQ or SQS or other things, then you're familiar with kind of the concept of using messages and topics for subscriptions. So you can process subsets of those, and really that's what that's about. API management gives you the ability to be able to define APIs. Each Logic app that you create has that API on the front of it. As you saw with me grabbing that callback URL and then using it in Postman. And if I build a schema on the front of that, then I can then kind of generate the Swagger from that by importing that into API management. And then I get a nice open API spec interface into my Logic app to make it super easy to consume from something else. Azure Functions, obviously that's our codeless FAS service, being able to write code in a language of your choice and integrate that with Logic Apps as well. As I mentioned, you can literally just write a function and call it from a Logic app. And then we have Data Factory, which is more of a data integration product, but it actually uses Logic Apps underneath it. So you create these things called pipelines, which gives you a set of steps, which are actually Logic Apps that get generated for you. And the Data Factory team actually uses our APIs to programmatically generate Logic Apps to do that. So they have their own graphical front end on top of that, that then allows you to have rich kind of data mapping and data integration on Azure as well. Okay, so just kind of looking at everything that's new, which I kind of covered a little bit in the demo, because what you saw there is essentially what we released in public preview about 6 weeks ago. The first thing to call out is I can actually do local dev now. So a lot of flexibility on the runtime, that we've containerized the Logic Apps engine, so you can now run it in Docker. You can just create a sort of Docker deployment image for that. Which means you can run it in Kubernetes, which means you can run it anywhere. So it's not just about being able to create and run Logic Apps in Azure anymore. You can deploy the Logic Apps engine to run on premises. You could deploy it into AWS or GCP and run it on their Kubernetes managed offerings as well, if you wanted to do that, or a combination of the two. We also have integration with Dapper, which I'll get to in a second, which is our microservices-based framework for building applications, which is open source and gives you the ability to use the Dapper bindings, which are essentially the way that Dapper generates work for functions and for workflow, and acts as a dispatcher and communication mechanism between the microservices. So using Logic Apps now, using a workflow engine as a microservice orchestrator is kind of interesting, because when you have very large numbers of microservices, the complexity can become overwhelming, and being able to view that graphically in a designer starts getting kind of attractive. And again, when you look at the stateless workflows that we have, being able to do that in a very performant way is obviously becomes critical when you're connecting lots of things together that do small kind of atomic units of work. You don't want the overhead of a traditional workflow engine to do that. So lots of interesting kind of use cases there that you can sort of put together. The second thing is a new designer, which is it gives you this kind of more compact, clean look and feel. If you've seen the original Logic Apps designer, you'll know that especially when I'm doing a presentation like this, you can only see a few kind of actions at a time. So we provide a more compact view by moving the configuration of each action out to that side panel that pops out. But underneath that, there's actually a new layout engine that we've introduced, which gives more control, and there's more features coming to be able to in a more opinionated way, be able to lay out where all those kind of boxes and arrows kind of sit, rather than kind of having that kind of grid-based look. You can sort of move things around and lay them out in a way that makes more visual sense to you, as well as being able to support more gestures like group, drag and drop, and other things to kind of actually sort of move and restructure your Logic app much easier. Which is often one of the use cases today that people jump to the JSON definition because it's easy to just cut and paste chunks of the definition around than it is to kind of move actions one by one. The VS Code extension gives developers a lot of familiarity, providing that local dev test in a loop. But also on the kind of back end of that, because Logic Apps can compose with Azure Functions, which composes with the Azure App Service, gives you a lot of capabilities like VNet integration, private endpoint support, CI/CD capabilities, things like GitHub Actions and other things to be able to automate your deployments and your deployment pipelines, which is kind of table stakes really for anything of any complexity. And being able to do that in a very consistent way, matters a lot, right? So we're not forcing you to kind of learn different ways of doing things based on the tools or services that you're using. Execution performance, I mentioned already around stateless, and then connectivity, as I just mentioned with VNet, private endpoint support, but also things like App Insights, which gives you the ability to do something called an application map of being able to construct and correlate events across services or across instances of things like Logic Apps. So when one calls another one, which calls a function, which then sticks a message in the queue and goes to a service bus or something else that then subscribes by another Logic App and does something else, like how do you know what's going on? And having that full correlated traceability is something that App Insights provides. And you can automatically generate a map of that running application to see how the data is flowing through it, which again is super useful from a debugging point of view, but also very useful from a monitoring point of view as well. Okay, I think I've covered most of these. Yep. So I'll just quickly whistle through this. And one thing I didn't talk about or show is something called automation tasks. So I was talking about integration and automation as being different. One place where this becomes quite explicit is something called automation tasks, which is based around in the Azure portal. So I can actually go to a resource and define a task or an action I want to perform on that resource. So maybe I've got a VM, and maybe I'll only want it to be running during my working day, 9 till 5, 8 till 6, whatever it is. Doing that today, it's possible, but it's not possible on all resources. So automation tasks provides a consistent way of being able to set up a rule that says, start the VM at this time of day, stop it at this other time of day, maybe send me an email if it failed to start. And this is available on most Azure resources. So, looking at storage, maybe I want to clean my storage up so I don't leave stuff lying around on a particular time schedule when, items in blob storage or something else get over a certain age. And we provide this through a set of templates that we provide. So you can just go to the resource and sort of step by step, say what you want to do with that resource, like start the VM, stop the VM, etc. But it's actually powered by Logic Apps, which is why it's in this talk. Because what happens is it generates a Logic App behind that. So you wouldn't know that. You're just basically just providing the parameters that's defining what the Logic Apps does, like the time of day you're going to start that VM. But once you've created that task, you can go behind the scenes, open it up in the Logic App Designer and extend and enhance to your heart's content. And this is a new feature that again went out last month. And is in public preview right now. So if you're used to using the Azure portal and have a need to kind of automate your resources to better manage them, then it's worth taking a look at that as well. Dapper, I kind of mentioned already that, but it's worth a sort of double click on this. The Dapper is our distributed application runtime. It is a framework for building microservice highly distributed systems. So you have the ability to write microservices in the languages of your choice and use Dapper as the communication substrate and sidecar in Kubernetes to be able to manage the coordination and communication between all the different component parts of your application, all those individual microservices. And it's not just about the communication. You've got a bunch of other things you usually need to take care of as well. You probably have some data, so you need some state management. You have things like authentication, so you need to worry about secrets. And you also need to worry about things like distributed tracing as well, so you can see what's going on in this highly distributed application, right? It's based on gRPC, so you get extremely fast performance with kind of the service-to-service invocation. And the interesting thing is this kind of Logic Apps integration here and also Azure Functions to be able to now do the microservice orchestration directly with Dapper by having workflow kind of built in It's exactly kind of what I showed here, but in the context of Dapper to be able to build, construct, and orchestrate microservices as well. So super interesting. Dapper is an open source offering that we provide with a very strong community based around that. So I would encourage people to take a look at that as well if that's interesting to you. Okay, so I think I'll just wrap up here and say, thank you for listening. A quick look at what I've been talking about is really that Logic Apps are really about cloud scale serverless workflow with hundreds of pre-built connectors. So instead of kind of writing code to connect all these individual applications, which gets kind of tedious, reading the API specs and figuring out all the data transformations and everything else you need to do to be able to call those things, authentication and all the other stuff. Having that all built in is a real time saver. Because of that, you can actually use it in a variety of different contexts, like application backends, integrating systems together, making data flow between them, and also automating things, as I showed in the Azure portal as well. But you also have code-based extensibility, the ability to be able to implement functions and integrate those, or just write code right there in the Logic App Designer as well. And with the new containerized runtime engine, you have the ability now to be able to essentially write once and run it anywhere, because you can run it anywhere that we can run a container, which is pretty much anywhere, right? So a lot of flexibility provided as well. A few resources, if you're interested in understanding and knowing more about this, you can just sign up for a free trial. And even just go to our GitHub repo and kind of pull the bits down and play around with what I was showing here with VS Code and with the runtime running locally. You can take a look at the docs, take a look at some of our customers and what they've been doing with this, and also send us feedback and follow us on Twitter. And with that, I will say thank you very much.
Thank you so much, John. I'm always impressed when people do live demos. We've got one question so far, and that is if Oracle is supported as an integration with Logic Apps.
Yes. A simple one. Yeah, so Oracle, I used to kind of, a long time ago, to sort of show all the connectors, right? We used to have like 20, I think, when I first kind of joined the team, which is like 5 years ago. And now we have hundreds, and it's just impossible to cover them all. So it's easy to sort of talk about the ones we don't have than the ones that we do. But Oracle DB is absolutely one of the ones that we have. And we've actually made a whole bunch of improvements to it recently, which you're going to see going out very shortly as well.
Nice. Well, thank you very much. That's the only question we have. I'll let you get on with your day. Next up, we have Yan Kui. Yan, if you want to take over the screen, we can get started.
All right. Hold on. Can you see me okay?
Yeah.
Okay, let me share my screen. Just 1 sec. Okay, let me know if my screen's up. My slides are up, sorry.
Yeah, we can see them.
Okay, cool. So I guess in that case, let's get started then. I guess first of all, good evening, everyone. Thank you for hanging around and listen to me talk about how basically I built a social network in just a few weeks using Graphql and Serverless. So this is actually something that I worked on recently on a client project where I built a backend for a new social network that lets you, basically mostly university students, register the sort of sports you want to do and find other people to do sports with. So you can arrange things like a basketball match and have a group chat, and you can have direct messages each other. You can arrange doing, I don't know, jogging together or something. So this was for a client who was privately funded. They were bootstrapped. So there's a lot of constraint on money and therefore development time. And they also need to get something ready in place before the semester started in September. So from the get-go, I had some pretty clear goals in terms of things I need to work with and help me drive my technology decisions and the approach I'm going to take. So we want to maximize speed of development because the client needs to get the app out quickly and they can't afford a long development cycle. And at the same time, this can easily scale to millions of users if it takes off. They already had the agreement with local universities in Belgium. And since we launched the app within the first couple of weeks, we have over 15,000 organic installs because the universities were helping out in terms of the promotion of the app And the universities were letting us manage their booking system for booking classes in the sporting centers as well. So it's been heavily used by universities in Belgium now. And also, you need to have a minimum upkeep because the client just can't afford to hire a full-time team to look after this. So it pretty much needs to run itself and not fall under. And also need to be cost efficient as well, especially as we scale to hundreds of thousands or maybe even millions of users as we open up to the rest of Europe and maybe the US later on as well. So the whole project was put together by a very small team of just 3 engineers, including myself. And I was working part-time, doing about, I guess, 2 to 3 days a week over the course of maybe 4 weeks or so, while also working on other things with other clients. So we built a mobile app. We also built a CMS for managing the universities, the contents, and the sporting classes that universities have in their sports center, and so on and so forth. So in terms of the full architecture, I'm not going to bore you with all the gruesome details, but here are a few of the key components and how they all fit together. So we were using CloudFront and S3 for image assets and things like that. We were using Cognito user pools for authentication. We had one pool for the mobile app and then another one for the CMS. The backend is all done in Graphql using AppSync. Again, we have one AppSync API for the mobile app itself and the one for the CMS. And they each have resolvers that point to DB tables for simple get, put, query operations. But for anything more complicated than that, I tend to have a Lambda resolver, which may or may not do stuff with DB. It may also talk to other services like Algolia, which should be used for search. And Algolia is probably the closest thing you're going to find to an Elasticsearch, or to a serverless Elasticsearch. And to get the data we have in DB into Algolia indices, we also use the DB streams to trigger Lambda functions. And then they got to synchronize the data and then put them into the Algolia indices so that we can search users and search activities and things like that in the app. So whenever a user updates or creates a profile, that's going to kick off a event in the DB stream, and the Lambda function is going to run and then update the index in the Algolia. And we also capture a bunch of BI events from different Lambda functions, and then we use Kinesis file host to capture those events, buffer them, and then batch them into S3 so that we can run BI analytics reports against them with Athena. There's also some batch jobs as well that runs against Athena data on a daily basis, and then they send out push notifications to remind you about that yoga class you booked that's going to come up, that's going to happen today, so that you don't miss the class. Again, this is not the full architecture diagram, but just a summary of some of the key services I used and how they fit together from a very high level. And moving a level up, we have multiple AWS accounts, which is a good security practice and helps you limit the blast radius of any security breach. And it also helps you consolidate billing and have the billing report across all your accounts. So we use AWS organization for managing the accounts. And I had the 4 separate independent organization units for dev, staging, production, as well as a org unit for accounts that manage shared resources. For example, there's like a shared user account for single sign-on and a shared account for collecting all the information from CloudTrail logs from all the different accounts. And then at the roots of the organization, I had a couple of service control policies. For example, to deny access to all AWS services outside of EU West 1, because I know that's the only region that we're going to use, at least for right now. So again, all of that work was done on the back end, it's all done by one person working part-time for a couple of weeks. And it's only possible because I could stand on the shoulders of giants. And really, most of the hard work was done by AWS and all these different service teams. And I can just use tools like Serverless framework to help me manage and deploy my resources. And my name is Yan Shui. I've been working with AWS for over 10 years now. And since 2018, I've been nominated as one of the serverless heroes. And the last couple of years, I've worked primarily with serverless technologies, including moving another social network to run pretty much entirely on serverless. And you can read about that particular journey on the link down below here. So nowadays, I spend half my time working with Lumigo as a developer advocate, and the Lumigo is a troubleshooting platform for serverless applications that makes it a lot easier for you to debug issues you have in production. And the other half of my time, I work as an independent consultant where I help companies adopt serverless technologies and go faster for less. In my spare time, I've written some books, published a few video courses, including I just got a new course that opened up for early access 2 weeks ago called the AppSync Masterclass, where you can learn to build a Twitter clone using AppSync, DynamoDB, Lambda, Vue.js, and so on. And I also run a podcast, a weekly podcast with other people who build things with serverless as well. So for most of you, I'm sure you've heard of GraphQL by now, but if GraphQL is new to you, then I'm just going to take a few minutes to talk about what it is from a high level. So basically, with GraphQL, you've got this schema language that lets you define the data types and the operations you can do on those data types, including queries for fetching data and mutations for updating them inside this like a GraphQL schema, which you can then run a GraphQL server that supports that schema, and the client can send queries to read and update data against your GraphQL server according to the schema that you've defined, which says what data is available and what operations you can do on those data. The server is going to validate the query, it's going to pass them, and then for different parts of the query, it's going to use what is called resolvers to basically fetch data from different data sources. And then the GraphQL server is going to then stitch the different parts together and then return it into a JSON structure, just the fields with just the fields that the client has asked for in the GraphQL query. As for AppSync, it's basically fully manage the GraphQL server, which lets you map those queries and mutation operations in your schema to different resources you have in your database account. It supports DynamoDB, Lambda, Aurora Serverless, Elasticsearch, as well as just raw HTTP endpoints. So you can use it in front of your existing REST applications, microservices, and so on as well. So as an example, if I've logged into the application as a logged in user, I want to fetch my profile from the app. And in this particular query, I'm able to fetch everything I need, including my profile ID, my first name, last name, gender, and the sports I'm interested in. All of this then are mapped to a request to the profile table in DynamoDB. So AppSync is going to fetch my profile using the authenticated user ID that Cognito has given to the AppSync resolver. And then for the list of sports on the profile, we only keep track of the ID of the sports, but then in the response, we want to hydrate the data so that you have to fully qualify the sport object with the image URL to show for the sport, the name, the display name, and so on and so forth. So what we can do is have a way it's called the nested resolver that runs on every single ID and then fetch the data from the sport table. And in that case, in the response, we have this fully formed sport object as opposed to just the ID. So we can do all of this in one query from the client's perspective, rather than multiple requests, which is going to save you a couple of round trips from the client's perspective. So it can solve what is commonly known as the N+1 request problem. And as for the activities I've arranged so far, I can have many activities. So when I fetch my profile, I don't want to fetch everything. I just want to fetch the first page of my activities for the next set of activity that's going to come in the future. So in this case, we can return a page of these results by making a request to DynamoDB using query, and then in the response, that's going to be a next token, which the client can then make another request to get the next page of my activities and so on. And again, this is not on the profile. This is a separate DynamoDB table altogether, but using GraphQL and AppSync, we're able to connect these two things together and allow the client to make one single request to fetch everything. And for the individual users that have asked to join my basketball match, for example, I also want to know their first name, their profile image, so that I can render them in the UI without having to fetch, making multiple requests to the server. Again, we can do all of that from a single client request, and that this is going to fetch those users' profiles from the profile table again. So it's very, very flexible. You can basically ask for any information that we expose to you via the schema. And where with DynamoDB, it's typically quite difficult to do a lot of those joins because you have to do them in your application. AppSync and GraphQL kind of solves that problem for you by doing all the joins for you, so that it becomes really painless for you to build something that's quite complex, and they still be quite easy to work with from the client's perspective. But you may also get a sense of danger here as well, that the client might end up asking for more information than is needed, and you can have very deeply nested queries that can start to impact performance if you're asking arrays of users, and for each user you ask for activities, which ask for users for other people, other profiles, and so on. So one of the things you can really do that's going to impact your performance and cost at scale is to have a good caching strategy. So with AppSync, it supports caching out of the box, and you can also decide to either cache the entire request or just cache individual resolvers, so that, for example, maybe I don't want to cache the entire request every time I want to fetch my profile, but the sports never change. So I can choose to only cache the sports resolvers so that they don't keep going back to the sport table. And there's another thing you can do is, for example, when we're fetching other people's profile, I have different types in my GraphQL schema, and that doesn't have as many information as in my personal profile. So there's less opportunity for me to nest the query even further from that point of view. So with a single query, I'm able to get back all the information I need on the front end to render my profile and show all the sports I'm interested in. And when I'm looking at other people's profile, I can also just make a single query and get everything I need from the front end to render everything we need on the mobile app. So AppSync itself is very scalable. It's got this GraphQL subscriptions implementation as well that can support the millions of connected clients. And it's a really good way to build the real-time applications where you need to push updates in real time to the mobile devices. And AppSync itself is also deployed to multiple availability zones out of the box. So also gives you a very good baseline for resilience. And the nice thing is that you only pay for what you use at the $4 per million request, which on the face of it may seem more expensive than things like API Gateway or the API Gateway, HTTP APIs, which is even cheaper than that. But one thing you're going to keep in mind is that with REST, oftentimes you have the N+1 request problem, whereby I make one request to get better profile, but then to show the sports, I need to make multiple requests to another API to get back the fully qualified the objects for the sports, and then to get the activities and so on. So in actual fact, in reality, oftentimes you end up making more requests to API Gateway if you're building a REST API than you would do against a GraphQL API. So even if it's more expensive per unit per request, it can still end up being cheaper because of the fact that you need to make fewer requests, which also improves the performance as well. As I mentioned earlier, supports caching, which charges you extra, essentially similar to API Gateway. When you're using AppSync caching, you're paying for uptime for a memcached node, and the amount you pay per hour is depending on the size of the node you want to use, which determines things like the amount of cache, the amount of memory available, and so on. It's also got the built-in monitoring with CloudWatch and the CloudWatch logs, and where you can get really high-level metrics like number of API requests, error counts, and the latency, which is great. But unfortunately, those metrics are all aggregated. So it's telling you the number of the number of errors for the entire API, but you can't really figure it out from that which endpoint, or rather which resolver was the problem. And equally, if you're seeing a spike in latency, well, which operation was causing the problem, it's really difficult to know just by looking at these high-level metrics. And as of now, there's no detailed metrics that you can enable on AppSync. What you could do instead is you can enable logging and enable resolver level logging and set it to all, in which case it's going to give you so much information about what's going on. You can use this to narrow it down specific requests that took a long time, and even to specific resolvers. So in that earlier request that we had, we have multiple resolvers to fetch data from different DB tables. And if one of them was slow, it's really difficult to know from just looking at a very high level metric. But with this resolver logs, you can see that. And then it becomes quite easy for you to figure out who the culprit is. And also, you can it shows you the request template as after it's been transformed. So in terms of debugging as well, you also it becomes really, really useful. For performance issues, though, you can also enable X-ray. And once it's enabled, you can see in X-ray like really what's going on inside a query. So in this particular example, you can see there's just a lot of things happening. A single request involved multiple calls to DynamoDB because of returning an array of sports in this particular case. And then for each sport, maybe we also, sorry, this is to get my profile. So we're fetching sports, we're fetching my activities and so on. And with X-ray, you can also see like a very high level view of the different services that you're using from your from AppSync API and the overall, I guess, latency from as observed by your application, as well as the health of those services you're using. And it gives you all of that. And I don't have to manage any servers, which is just amazing. And so you may have also noticed that even in the examples I've shown so far, I've got quite a few DB tables. And I think at this point, I probably have about 15 different tables to be precise. And if you've been sort of following what's happening in the sort of DB space, you may have heard about this whole single table design thing and wondering why I didn't condense a lot of these tables into a single table. Well, I do use some of the modeling techniques that goes with single table designs. And I do put some of the things, the entities into one table where it makes sense because I need to always query them together. But other than that, I don't see why I should force myself to put everything into one table. It's in most cases just impractical. And I'm also quite careful with using global secondary indices, which you end up using a lot when you've got all these different entities in the same table. And there's some serious impediments when you have too many global secondary index. For starters, CloudFormation can only update one global secondary index at a time. So if you ever need to add a feature that requires two global secondary index in one update, then you're screwed. If you ever need to rename a global secondary index, you're also screwed. You have to be really careful in terms of how you manage your commits and when you push your CI pipeline so that you only update the one global secondary index at a time. And also, when using one table for all these different entities, it becomes really difficult for you to understand what data you have, and you have to always keep in mind the sort of suffix, the prefix you're using for different entity types, and your code just generally becomes a lot more complicated and hard to maintain. And also, when you're building something new, you haven't figured out all your access patterns yet, and whenever you change your mind, those changes can be very difficult, especially since you can't deploy more than one global secondary index update in one CloudFormation update. So do you really want to deal with that? Personally, I don't. So I've used those modeling techniques very conservatively and pragmatically, only when they make sense. And also when I need to read a couple of related items from different tables in one request, which is one of the reasons why you hear people talk about how single table designs is more cost efficient. Well, AppSync is going to take up all the complexities in terms of stitching things together. However, another argument could be it's cheaper because with the way DynamoDB calculates cost, if you read 4 items in a single query, is more cost efficient. It counts as one. It can potentially count as one request unit versus 4 separate get from 4 different tables. But if I was to use a single table design, then I'm going to end up having to write a lot more custom code in the VTL and to make a query to fetch 4 different entities, and then in my result, pick out the right one and then put them into the right place in the JSON response. And it just becomes a lot more complicated, especially when it involves writing custom VTL code, which is just, let's just say, it's not everyone's cup of tea. And in terms of cost saving, I mentioned the potential cost saving is that, well, you can make one single query to fetch multiple items, and the way that read units are calculated based on item size and all of that means then potentially there's one request unit versus 4 separate get items from 4 different tables, which counts as 4 separate read units. But you know what? A sensible caching strategy is going to save you far more than a single table design is ever going to save you, because you're going to cut out most of the requests to DynamoDB before they even happen. And also, maybe the cost saving you are potentially making against those DynamoDB operations, you're just going to waste more money on the staffing, because your code is harder to maintain, it's more difficult to understand, and probably more likely to get bugs. And in my case, since we've gone live, I've had the steady 99% cache hit rate on average throughout the whole day. So our DynamoDB bill is pretty minimum, and we've been live for more than a month now, and up to, I think I took this screenshot maybe almost a month ago now, actually. So now we're up to about 250,000 requests per day on average, and most of those requests are pretty intense. We're fetching a lot of data from DynamoDB, and if you look at our DynamoDB bill from the last month, it was what was it, $4. And a super high scale, if you like, Amazon.com, then sure, those small cost savings is going to amount to pretty significant amounts. But for most people, if you got good caching strategy in place already, then you're probably not going to save much money from single table designs. For this app, certainly we don't need to optimize for the absolute best performance and scalability, and the multi-table design is more than sufficient for our needs, at least for the foreseeable future. And the thing with single table design is that it's just far more complex, and I think in very few cases would that complexity be justified. And because also, I don't remember who said this, but I prefer to design my system as if it's going to be run by idiots, because one day it's going to be. And in most of the time, the idiot is myself in 3 months' time, when I can barely remember why did I did something. And certainly when I look at a table, I want to understand what data I have there and be able to work out my access patterns rather than having to look up whatever does GSI 13 means in my single table design. So just to clarify, I do use single table design, the techniques, but I don't force myself. I don't force using a single table on myself because it's just arbitrary. Why 1 table and not 2 table, and why not 4 table and 10, 15? So that's a bit of a rant on the single table designs. I've seen a lot of people run into problems in production with that type of approach. Not to say that the modeling techniques themselves are not good; they're great, and you should use them. But forcing yourself to use just 1 table, that doesn't make sense to me. In terms of authentication, as mentioned earlier, we use a Cognito user pool, and I set up identity federation as well, so that users can sign in using Facebook and Apple. And on the client side, we use the Amplify.js library to integrate with Cognito, which really makes things quite simple as far as the authentication is concerned. However, I also didn't use the Amplify CLI to create and configure the Cognito user pool. I configured it with CloudFormation in the Serverless framework, because, well, I know how to do it already. I've done it many times, and if anything, I kind of need to know what's been configured. And while I think the Amplify CLI is great for quickly bootstrapping a new application, especially for a team that just doesn't have a really good or strong experience with AWS and Cognito, it really helps you get something going quickly and give you some good defaults as well. But it also hides a lot of underlying details that you should be familiar with how your application is working, especially when everything still gets translated to CloudFormation. So you're still bound by all the limitations that CloudFormation has. And I've heard multiple people get stung by this, that when they decided to make some changes, it ended up spitting out CloudFormation changes that CloudFormation just won't do. For example, when you want to change the schema index, a schema for a DynamoDB table, CloudFormation is not going to let you do that. And then at that point, you kind of just stuck. You don't have control of the underlying implementation, and you're leaving a lot of control into the tool that you don't understand what it's doing for you. Amplify can also, on the other hand, Amplify could also provision the table for you as well based on your GraphQL schema and on your model, which again, a lot of the time I don't agree with the decision that it makes. For example, how it defaults to using scans for list operations. And in this particular case, and in fact, in most cases I can think of, the DynamoDB schema and access patterns are really important. with potentially huge scalability and cost implications as the application scales. So I want to have tighter controls around that, or at least have more intimate knowledge of how my application access the DB tables and how my access patterns evolve over time, so that I can tightly control and tune the access pattern so that I get the best performance and the cost without having to without running into some obscure problems when it comes to the next time it comes to deploy my application in production. And ultimately, I just think it hides a bit too much details from you, and not being able to drop down to the CloudFormation level when I need to is going to restrict me when I need to make certain changes in my application. And also, we built a CMS as well, which also uses amplified JS on the front end to authenticate the user to the Cognito user pool for the CMS application. And as an admin for the app, which would be basically the two founders, they can onboard the new universities to help them configure the default list of sports you're going to see in the app. And when you onboard a new university, we also invite an admin staff from the university to the CMS so that they can manage the university details. They can write and update their sporting programs and things like that. And as part of that, we generate a random password, a temporary password for them when we register the user in the user pool, which is again all done by a Lambda function behind the CMS AppSync. And the user is then able to log into the CMS. They can update their password on the first sign in, again, all Cognito. And the nice thing with the Cognito and the AppSync integration is that in the CMS, in the CMS user that we create for this admin staff, we will add them to the university group to identify them as the university admins, and then we'll use a custom attribute to tell us which university they are the admin for, which is then passed along to the AppSync resolvers by Cognito when the user interacts with the CMS AppSync API. And at no point do we allow the client to pass the university ID to the backend to say, hey, I'm the admin for this university. Let me access the data or let me change the data. It's always based on your identity, which is a really important detail to remember. And when you're the admin for university, you've got different options in the CMS compared to when you log in as the founder. And in this case, you can only do things that are limited to your university. And the thing with AppSync is that you can restrict access to specific operations using Cognito groups. All you have to do is to say that for this operation, only the Cognito users in this admin group can access this endpoint, and this other endpoint can only be used by the university admins, which in this case will be operating against just the university that they're the admin for, which makes building this sort of multi-tenancy aspect of the CMS a lot simpler. And if you don't specify any specific options, then any logged in users can do these operations, like uploading a URL, uploading an image for your university profile, background, and things like that. So let's move a bit closer to the code. I use the Serverless framework to help me package and deploy my application. It's mature, it's got a great community around it, and it's very extensible through a whole host of different plugins from the community. And we're going to see two of them in a minute, which I've used very extensively here. And I was also very familiar with the Serverless framework as well. It's been my go-to option for a few years, and I'm really pretty proficient with it. In this case, I've got one repo for the whole backend, and everything is configured in the one Serverless YAML, and it's deployed as one CloudFormation stack. And so resource reference and all of that is very straightforward. Even as the project grew, and to deploy, I just have to run one command, serverless deploy, and that's it. And to make it easy for me to configure all of these resolvers I had with AppSync, I was able to use the Serverless AppSync plugin, which made things a lot simpler, really, really simple. So I've got two AppSync APIs, one for the app and the one for the CMS. So I broke them out into their own files to keep things a bit more manageable in my Serverless YAML. And in each of those files, we will define our AppSync API, where I will configure the Cognito user pool to use for the API. I'll configure the logging. So in production, those resolver logging is amazing, but they spit out so much data that they will cost you a lot of money in the CloudWatch logs. So we kind of disable the resolver logging, resolver logs in the CloudWatch for production because of the cost implication. But we do some sampling instead. I do sample those resolver logs for about I guess 3% of the logs. And then I'll configure my resolvers and data sources in the same file for a lot of these resolvers. We just go straight from AppSync to DynamoDB. So the request and response template have to be written in the VTO, which is also the same template language that the API Gateway uses. So I'm kind of familiar with it, but really it's kind of weird and not everyone's cup of tea. The good news is that for most cases, when you're talking to DynamoDB from AppSync, you just grab the example from the official resolver mapping reference page, and then put it in, and then change the name of the fields and update the expressions and whatnot. So you don't really have to write many custom VTL code unless you're running single table design, in which case you probably end up writing a lot more custom VTL code. As the project grow, I pretty much hit the 200 resource limit, which unfortunately, well, I guess fortunately nowadays it's been up to 500. Unfortunately, was I still had that 200 limit to deal with at the time. So I used this split stacks plugin, which can split my one stack into multiple stacks by splitting some of the resources into nested stacks. And the great thing here is that it lets you control the splitting logic yourself, which is very handy. The good thing about this approach is that you don't need to refactor your project. The plugins will just move resources around and put them into the nested stacks while still preserving all the sort of existing references and so on. Where you got to be careful though is not to create some kind of a circular reference where maybe you got resources that are referencing resources in another stack and are referencing something else, and vice versa. You also have to be mindful about other limits, like the number of parameters and outputs you can have per stack, which was 60, but now it's also been up to, I think, 200. So I had to be quite careful in terms of how I organize my resources into those stacks, so that I don't run into those circular references and don't run into those number of parameters and outputs limit. And if you look at the sort of resource graph you have for AppSync Resolver, there's quite a few different types of resources. You got your data sources, you got your IAM rows, the Lambda functions, DynamoDB tables, and so on. So after a few iterations, I finally found a way to actually just keep that allows me to keep growing the project, which when I took this screenshot had over 200 resolvers across the two AppSync APIs and had over 639 resources, which now has also grown even further than that. So the approach I took allowed us to just keep adding more resources without having to worry about running into whatever size limit we have with the CloudFormation stacks. So the best way I found is to start from the data source and then find the Lambda function, well, basically everything that depends on it or it references, and then put those into a group, and then take those groups and put them into nested stacks so that you can minimize the number of references across different stacks, and therefore remove the potential to have circular references, but also reduce the number of parameters and outputs you're going to need, because you're minimizing the number of references across different stacks, and therefore you don't need to expose as many things as outputs and then use them as parameters. Which brings us to CI/CD. Since the whole code base was in GitLab already, I just used the GitLab CI/CD. And the one technique I've used in most of my projects is to install the Serverless framework as a dev dependency on a project. So I don't have any other extra dependency on a CI server, and I just have a helper script in my package.json that runs npm CI to restore all dependencies to the exact version I had in source control, and then serverless deploy to trigger the deployment using the version of the server framework that's been installed on the project. So CI becomes super easy, literally just two-step thing, and I've got a script that just runs that gets kicked off by the CI server. In terms of testing, one of the challenges with using something like AppSync is that it's a bit of a black box. So how do you test it locally? There are tools that can simulate the AppSync locally, but I usually don't bother with them because they don't cover everything, including IAM policies. And honestly, also most of the time, the VTL templates are so simple when you don't have to write custom VTL code, so they just work. Where things tend to go wrong is in my Lambda functions, where I do more complex things. That said, where I do have to write the custom VTL code, I do write the unit tests for my VTL templates, and in my and you could write unit tests for VTL template code using some of the tools that that's part of the Amplify, I guess CLI simulate, CLI tool, but they also publish them as npm packages. So I actually covered this quite extensively in my AppSync masterclass. So if you want to learn more about that, feel free to check that out. As for Lambda, where I do most of my complex stuff, I like to test my functions integration with other services like Algolia or DynamoDB by running the function locally, but talking to the real DynamoDB table or the real Algolia index. So for those services, I don't tend to use mocks or stubs or simulate them locally with things like local stack, which I find takes too long for you to configure them properly, for them to work, and also super brittle, that it breaks really easily, and sometimes you get weird errors because of the local stack, errors that you never see, that just doesn't exist in production. So a lot of time I find it easier when I'm running this test, just provision the tables and then run the test by running my code locally to get a good confidence that what I've got actually works in my code. And then after that, I will deploy the code and then I'll run end-to-end test against the deployed AppSync API and run user stories like, oh, someone creates a profile and then they did a search and find other users and then they asked to join other people's basketball match and so on. And I'll run this against the deployed GraphQL endpoints in AppSync. So these will always be run after post-deployment. And if you've got any sort of failed end-to-end tests, then great. Use them as a signal and as a rehearsal for how do you debug real problems in production. If this is going to be difficult, then guess what's going to happen when you do have a problem once the system is live. Use the fact that your end-to-end tests failed end-to-end tests are difficult to debug as a signal that you need to improve your logging, how you're monitoring the system, and maybe enable X-ray tracing. Because if you're struggling to debug failures in a controlled environment like your end-to-end test, then you're going to have a much bigger problem when this thing is running in the wild. So don't optimize for your comfort with all these local simulators. It's a false sense of security. And finally, in terms of the AWS organization, how I set it up, we've got the org units that I talked about earlier with different accounts underneath them. So I use a tool called the org formation to help me manage everything, which gives me infrastructure as code using a syntax that's very similar to CloudFormation. So I can use this to create the landing zones for basically a boiler template for what a new account should have. Things like KMS encryption keys, default VPCs, and the things like that. So in this case, I was able to declare a number of the master AWS account as the root of my organization. Again, all inside code using a syntax that's very similar to CloudFormation. And I was able to provision new accounts and set up a budget alarms with just a few lines of code. I can attach those accounts to my org units, which again, all inside this org formation code. And I can also configure the top level service control policies. For example, here, I know that the only region we're going to use is the US one. So I set up the SCP that denies all actions against regions other than US one and apply the policy to the root root of my organization, which then gets applied to all the different accounts. And also configure my password policy for AWS users and use this policy in all of my accounts as well. And when I want to make any change, I just have to run one command to update my entire AWS organization, including the configuration of my landing zone, which is something that Control Tower doesn't really do. Control Tower lets you provision new accounts based on some template or factory that you have. But once you update your template, it doesn't really have a mechanism for you to update those existing landing zones that you already provisioned. But org formation lets me do that by updating the existing stack that's been deployed to all these different accounts. And to configure my landing zone, I can configure what is called a task, where I can specify basically a CloudFormation template and say, provide the bindings to my organization, which basically says that which resources from the template should be created in which AWS account by binding the resource to org units or to specific accounts or to accounts that has got a particular tag that we've defined. So here's an example of one of these templates where I've just a normal CloudFormation resource for an IAM user, but I can bind this resource to a subset of the accounts in the organization using this concept of binding, which basically filters out all the accounts by org unit in this particular case, or by account name or tags and so on. And here I can iterate through the AWS accounts that are provided by the binding. And don't worry if this looks a bit weird and alien, because it probably is. But once you spend a bit of time with org formation, you start to make a lot more sense. Then I can then iterate through them and then create this resource, in this case, with assume role policy against multiple accounts. And again, when I want to update my landing zone, I just run one command and job done. So it's really, really powerful tool. There's a bit of learning curve involved, but I do recommend that you check it out. It's available on GitHub, and it's been used by companies like MoneyU in the Netherlands and by Steady in the US as well. And that's kind of the three main tools I've used on this project. Server framework for deployment automation, AppSync for the managed GraphQL server, and org formation for automating pretty much everything around my AWS organization. If you go back to the goals I had started with, in terms of speed, getting everything done on the back end in the 4 weeks is pretty good going, considering the amount of stuff that was involved. And I was only working part-time on this. So speed of development, check. AppSync can scale to support millions of users, absolutely, so check. I have 0 EC2 instances, so no server to manage, no networking, no VPCs, and none of that. So, check, 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 and check. And as for being cost efficient, so after we went live for about a month and had about, I think at that point, 15,000 organic installs and averaging around about 150 to 200,000 API requested per day. The AWS bill last month in October was about $60, and most of that was on AppSync caching. And we were only using about 5% of the cache capacity. So this $32 is going to be pretty flat for the foreseeable future, even as traffic goes at 10x. And it's going to save us tons of money on the Lambda and the DynamoDB cost. And besides what you see here, there's also maybe, I think, $15 or so for CloudWatch logs and for X-Ray as well. So all in all, it's been pretty reasonable price to pay for something like this. And on the latency in general has been really good. P99 stable around 500 milliseconds during the day when people are using it. But when you use it in Belgium, you can see those P99 go up because you've got there are more Lambda cold starts and other things like that. So so you do get a bit, I guess some of the tail latency becomes a bit more unstable when there's not many people using it. But overall, we are still very happy with what we are seeing in terms of performance, and certainly in terms of how the system has scaled and keep a pretty steady and cost-wise. And that's kind of the end of my talk, exactly about 45 minutes. So as I mentioned earlier, I spend most of my time as an independent consultant. So if you want to see how Serverless can help you go faster and maybe need some help with your team, then let me know. Check out theburningmonk.com. And also, I've got a new video course on AppSync, so also check it out as well. It's now open for early access with a pretty big launch discount. And with that, thank you again. And let me know if you guys have any questions.
Thanks so much, Ian. We've got a few questions for you. So the first one is from Andrew. He says, happy to see no single table design. Have you tried using Aurora Serverless?
So happy to see no single table design. And have I used the Aurora Serverless? No, I haven't. So for this particular project, we haven't needed anything that requires something like a relational database. some of the problems that people run into with DynamoDB is that it's really difficult to do joins. But with AppSync and GraphQL, you kind of don't need to do joins because it's done at the application level, and AppSync and GraphQL can do it for you. So I haven't needed to use a relational database on this particular project. I'm kind of grateful for that, because otherwise I have to configure VPCs and all of that other stuff as well.
Okay, cool. The only other question is, does this multiple table fetch happen in parallel? This was quite early in the talk, the question came through.
Yeah, it can do. It depends. So in the example that I think, let me share my screen again to walk through that example we had at the start. So you can probably visualize it a bit better. Let me just quickly find that slide. Okay. Here we go. Let's see, where's Zoom? So if you see this query, to fetch the profile, you do need to run this first to find out what sports IDs you have. But after that, all the queries, so multiple gets to different to get different sports, those can happen in parallel, and those can hit different caches as well. So that maybe one sport like football is very popular, so you load it all the time, so it's in the cache already. But one guy is doing something I don't know, obscure, like Aikido, maybe probably not that obscure, but imagine someone is doing Aikido, and then you have to load Aikido, and that's the first time you've done it, so that's not cached, and that has to go to the sport table. So all of this can happen in parallel, and so does the activities, because once you've loaded the profile, we have the profile ID, and we got a source object, and activities. This is a separate, I guess, field in your schema, in your type, and this can be attached to a different resolver, which can then run in parallel. But if you need to load the users inside the join request, so people are asking to join your basketball match, then you need to load their profile. This can only happen once you've got the activities back. So as much as possible, they do run in parallel, but it depends on the structure of your query. Well, sorry, of your type.
We've had a few more questions come in. What is AppSync latency with Lambda resolvers compared to API gateway?
AppSync has very little overhead in terms of calling Lambda or DynamoDB. So I would say think of them as being the same, because API gateway itself has got very low overhead in terms of latency as well. So whatever latency you're going to be you're seeing, it will be coming from your Lambda function, and the cold start is not going to be coming from AppSync.
Okay, cool. Also, have you tried AppSync with over 1 million requests per minute?
No, don't have anywhere near that kind of traffic. Hopefully one day, but no. If you're and honestly, if you're hitting that kind of scale, then I will probably suggest moving away from the running something like AppSync, because at that point you're talking about the pretty high throughput that can be quite expensive running AppSync versus maybe just running a Apollo server in a fleet of containers. So at some point, and the same with all serverless components, that at some point, if you're running high enough throughput, then you may not want to run them in the serverless components anymore. It might be worth to run some stuff in a container for the things that are running at super high scale and therefore super expensive. Because if you do if you crunch numbers, 1 million requests per minute, that's $4 per minute times 60 per hour times 24 times 30. Those numbers start to become pretty significant. So at some point, it will be cheaper and more cost efficient on your total cost of ownership to run stuff in containers. That is, if it's going to cost you, I don't know, 10 grand a month to hire engineers that can help you build your containerized application environment, then when you're doing 500 requests per minute, it's not going to be worth it. You're going to spend so much more on staffing than your infrastructure. Then no, don't do it. But when you're talking about a pretty significant amount of money you're going to be spending on infrastructure for using AppSync, maybe it's worth hiring that 10,000 a month guy to help you run your containerized environment.
The last question we have comes from Matt. He asks, have you considered swapping from serverless framework to SAM?
No, I haven't. I never had really the reason to, partly because the server framework, well, one reason I always prefer server framework over SAM is that I am limited by SAM in what it does, whereas with the server framework, I can always either write a plugin to extend what it does or to disagree with how it does it. And I can do this either by writing a plugin myself, or in most cases, find a plugin that somebody else already did. So the kind of problems I discussed earlier in terms of running to the CloudFormation stack resources limit, well, there's a plugin that's sitting there that's available that help me solve this problem already without me having to do anything. With SAM, I have to find a solution myself. And also the AppSync plugin, it makes my life a lot easier. Whereas with SAM, I think, I don't know if it supports AppSync at the moment, maybe it does, I'm not quite sure. But SAM doesn't have the same extensibility that I need for my projects. And in the past, I've had problems whereby SAMs configure something in a certain way, and that the only way for me to disagree with SAM was to write my own CloudFormation macro that changes the CloudFormation template that SAM generates once his CloudFormation change one thing, one lines of CloudFormation code. And if you think that's silly, it's because it is. And yeah, so yeah, I always prefer the server framework because of the fact that it's really extensible, and there's an escape patch for me to disagree with the framework.
Okay. Well, thank you very much for joining us, Jan, and thanks everyone for joining us today. Our next meetup will be in about 2 weeks. We'll announce it tomorrow. Have a good night, everyone.
Cheers, guys. Bye-bye.